Question is from complex numbers. He has given that if omega minus or w, you can consider w minus w conjugate z by 1 minus z is purely real. The first condition he has given that the given complex number, this total complex number is purely real, where w equals to alpha plus I beta, and given that beta not equals to 0, and another condition he has given that z not equals to 1. Okay, z is over here and z not equals to 1, then the set of values of z is, okay, then what the set of values of z. Okay, read the question again. What he has given: if some complex number is purely real, when a complex number is said to be a purely real. Yes. So if a complex number z we consider, then complex number z is said to be a purely real if its conjugate equals to the complex number itself. Then only we can say that the complex number is purely real. Okay, so this is the concept he has given. Now he has given that w minus w conjugate z by 1 minus z is purely real. That means now we can write it as w minus w conjugate z by 1 minus z is purely real. Means what you have to use? The total conjugate. Okay, the total conjugate, otherwise z is equals to z conjugate, so which is equals to its conjugate. What it is? W minus w conjugate z by 1 minus z whole conjugate. If z equals to its conjugate or z conjugate equals to z, we can say that the given complex number is purely real. Okay, so now this is the first condition. Now we will try to solve this condition. And what he has given the condition in the RHS, he has considered as what it is from z1 by z2 whole conjugate, which can be written as z1 conjugate by z2 conjugate. Okay, now we can write it as w minus w conjugate into z by 1 minus z equals to, so w minus w conjugate into z whole conjugate by 1 minus z whole conjugate. Okay, and we have that what it is, z1 plus z2 whole conjugate can be written as z1 conjugate plus z2 conjugate. Now we need to use the condition as in the RHS as w minus w conjugate into z by 1 minus z can be written as w conjugate minus, okay, if it is plus or minus, and we can write it plus or minus over here, then we can write it as w conjugate z whole conjugate. Okay, this is the one term and this is the one term. Next we can write as, and 1 minus z conjugate means 1 conjugate real number, means the conjugate itself it is only, then 1 conjugate is 1, and we have z conjugate. And over here we have what it is, some z1 into z2 conjugate, which can be written as z1 conjugate into z2 conjugate. And we have another condition, z1 conjugate whole conjugate is nothing but it is z1 itself. Simply the properties of, okay, he is using that the properties of the conjugate. Now see here in the 2 or 3 steps how many properties he used. Okay, so that means now we can write this is as RHS equals to w conjugate minus some, what it is, z1 z2 whole conjugate can be z1 conjugate omega, that means w conjugate whole conjugate, we can write it as a w into z conjugate by 1 minus z conjugate, whereas in the RHS we are having, so w minus w conjugate into z by 1 minus z. Now cross multiply these two, then what we'll get if we cross multiply these two, we can write this is as w minus w conjugate into z, okay, into 1 minus z conjugate, and which is equals to w conjugate minus w into z conjugate into 1 minus z. Okay, now try to simplify this. What will get w into 1 w, okay, we will get over here the w minus w into z conjugate minus w conjugate into z, and we will get over here as a minus into minus plus w conjugate into z conjugate, which is equals to w conjugate into z conjugate, which is equals to we can write over here it is as W conjugate minus what it is W conjugate into Z minus, okay, W conjugate into Z minus W Z conjugate, minus into minus plus we get over here as W into Z conjugate we will get over here. Now what it is in the LHS, the minus WZ conjugate and minus WZ conjugate will be cancelled out, and minus W conjugate into Z minus W conjugate into Z, and we have over here W plus W conjugate into Z conjugate equals to W conjugate plus W into Z conjugate. Now take into the RHS side. We can write as W plus W conjugate into Z conjugate minus W conjugate, and we can write this as minus W into Z conjugate equals to 0, and we can write this as W minus W conjugate as a one term, okay, plus if we take, okay, so W minus W conjugate, and if we take minus Z into Z conjugate as a common, okay, consider over here, if we take what it is minus Z into Z conjugate, then what will get minus Z into Z conjugate means we will get W, and over here we will get it as a plus means minus W conjugate equals to 0. Just simply multiply, what will get minus W into Z conjugate minus into minus plus W conjugate into Z conjugate. Now we can take W minus W conjugate as a common, then what will get 1 minus Z into Z conjugate equals to 0. Okay, right. So here what is W? So W is here as given, it is as W equals to in the question alpha plus I beta. Then substitute over here. So what is W? Alpha plus I beta, okay, minus of W conjugate. W conjugate means alpha minus I beta. So which is the given condition. And what it is another property, Z into Z conjugate can be written as 1 minus mod Z whole square. Okay, Z into Z conjugate can be written as mod Z whole square. So if we simplify this, alpha plus I beta minus alpha plus I beta, will get over here it is as 2 I beta into 1 minus mod Z whole square equals to 0. Okay, so this is obtained. Okay, if A into B equals to 0, either A equals to 0 or B equals to 0. So that means the beta equals to 0 has to be obtained here. If we consider the beta equals to 0 over here, so what it is he considered as a beta equals to 0. Okay, 2IB equals to 0, and another thing is 1 minus mod Z whole square equals to 0. The two possibilities we obtain over here. So if we obtain the two possibilities, but in the question he has given that the beta not equals to 0. In the question he has given that beta not equals to 0. So beta not equals to 0 means do not consider this case. Okay, this case is not considered. So obviously what is the condition we obtain? 1 minus mod Z whole square equals to 0, and given that beta not equals to 0 in the question. Okay, just observe here, every point in the question is important to us. Okay, every point in the question is very important to us. So we are using every condition what he has given in the question. So now 1 minus mod Z whole square equals to means mod Z whole square equals to 1, and we can write it is as mod Z equals to 1. Okay, mod Z equals to 1. Okay, finally we obtained it is as mod Z equals to 1 as the solution. Now go back to the what he has given the question options. What he has given, the options has given is as the values of Z as, so Z such that mod Z equals to 1. Okay, this is the one. Mod Z equals to 2. Option B is wrong, and option C is mod Z not equals to 1. It is also wrong. Why? Because we are obtaining mod Z equals to 1. And option D, Z is such that mod Z equals to 1 and Z not equals to 1. So we obtained the option A. Is it clear? Okay, right. So the answer is option A. No. But again read the question. What he has given? Z not equals to 1 is also a condition he has given. So the option is, correct option is answer D. Why? Because from the solution we are obtaining it as Z mod Z equals to 1. and in the question he has already mentioned that the z not equals to 1. Okay, if z not equals to 1 only we are obtaining this condition. Okay, so z not equals to 1. So the correct option for this one is, even though the option A is correct, but the appropriate answer, it has to be mod z equals to 1 and z not equals to 1, which is the appropriate option. Okay, thank you. So I think you understand how to solve these type of problems.